All right, so our next parent function is our square root function. Same thing, I'm going to create a table of values. So I've got x and y. I'm going to go from -3 to +3. So -3, -2, -1, 0, 1, 2, and 3. So right here, I'm going to take the square root of -3, which is impossible using real numbers. So this will give me an imaginary number. And so it's not really useful to use any negatives when we're doing a square root function, okay? So we're going to cross out these three values. So now when I want to take the square root of 0, that's possible. You end up getting 0. So right here, this value right here will equal 0. The square root of 1 is equal to 1, so this value right here is 1. Now I get to the square root of 2, and I get an irrational number. So I don't want to deal with that either. For this type of a problem, it's a good idea to be pretty strategic about what x values you place in your table of values. So I'm going to create a different chart, okay? This time I'm going to create a chart of positive perfect squares. So my first positive perfect squares or 0, so non-negative perfect squares. So 0, 1 is a perfect square. The next perfect square after 1 is 4. The next one after that is 9. And I'm going to stop there because my graph only goes out to 10. Okay? So then when I figure this out, well, the square root of 0 is 0. We already figured that out. The square root of 1 is 1. The square root of 4, so here this is saying that y equals the square root of 4, so y equals 2. And here y equals the square root of 9, so y equals 3. So I'm going to go ahead and graph out these points. So 0, 0 will be right here, 1, 1 will be right here, 4, 2 will be right there, okay? And then 9, 3 will be right here. So that way when you graph it all out, this is what your square root function looks like. So you end up getting y equals the square root of x right there. All right, so again, with question number 4, we chose numbers, first of all, that we could even, that are even part of our domain, that we can actually find the outputs for. So we completely ignored our negative values because it's not even in the domain. Although non-perfect squares are in the domain, because if you look right here, this function is continuous. It keeps on going and going and going. So we just didn't put 2 in our chart because we'll get a crazy irrational value, but you can still include it if you want to and approximate where it should go on your graph. However, with all these other examples, like example number 3, you can use any x value you want. You can raise 2 to any power, okay? You can take in question number 2, you can take the absolute value of any number. So any x value goes here, okay? And any x value goes here because y will equal any x value that you want. So the most important thing for you guys to understand is that you have to understand when the domain is limited. In question number 4, if it says y equals x squared, x is your what's defined as your domain. So your domain is all the x values that work. And you can square any value you want. So for this one, I'm going to create another chart, and I'm going to use the same values that I used for most of my examples, which is from -3 all the way up to +3. Okay, so y equals, the first value is -3, so I'm going to take -3, I'm going to remember to put parentheses around it, and I'm going to square it. -3 squared is 9, okay? And then the next one is -2 squared, which is 4. The next one is -1 squared, which is 1. Then I've got 0 squared, which is 0. 1 squared, which is 1. 2 squared, which is 4, and then lastly 3 squared, which is 9, okay? So if you look right here, if I were to graph this out, this is what my graph would look like. -3, 9, right here, -2, 4, -1, 1, 0, 0, 1, 1, 2, 2, 4, and 3, 9. Okay, so this is my parent quadratic function, y equals x squared. So everything else that we graphed out in the last unit, every single quadratic function was basically this parent function with some type of a transformation done to it. And we're going to talk about how to do that in the next unit. So one other thing that I want to make sure that you guys understand is that y equals x squared and y equals the square root of x, these two graphs are inverses of each other. And if you remember, when we did our reflections, we learned how to reflect over the line y equals x. So if I were to take this graph right here and reflect it over the line y equals x, and I don't want you guys to graph this out right now, I just want you to just follow along with what's happening right here. So if I were to reflect this over the line y equals x, this point right here would stay right at 0, 0, right? 1, 1 would stay right at 1, 1. But then this point right here, when I graph out 2, 4, it's going to now go to 4, 2. Because it's going to go diagonally across, right? So this is one box across. Now it's one more box across. So this is at 4, 2, okay? And then this one right here, when I count diagonally across for this one, it will end up being at 9, 3. So this right here should look familiar to you. It's basically this graph right here. So it's just a reflection over the line y equals x. But this part right here will also reflect over and will end up looking like this, which is impossible because then it won't be a function. It doesn't pass the vertical line test, okay? So that's another reason why when we do our square root function, the parent function is only defined in the first quadrant up here, while the square function is defined in both quadrants. 1 and 2, okay? All right.